Okay, before we start, I want to remind you that with this chapter, we're doing daily quizzes. So next class, you're going to have a daily quiz on what we learned today. Today, we're only learning simplifying and multiplying. So there's this set of notes, we're not going to get through all of them, okay? If you put your calculator away after the quiz, can you take it back out? Because there is something that we're going to do on our calculator as well. And again, we are having a quiz next time. So make sure you're asking good questions as we're going over the notes and that you have your assignment done prior to next class. Okay. Oops. So we are simplifying rational expressions today and multiplying rational expressions. That's what we're doing. Does anybody remember what a rational expression means? Well, we did equations last time, but just the word rational. Somebody remember? Ratio, but what's it mean? What's a ratio? Fraction. So these expressions are fractions of polynomials. Polynomial on top, polynomial on the bottom. A rational expression is in simplified form when its numerator and denominator have no common factors other than 1 or negative 1. It's simplified when you cannot factor and cancel anything. We know how to factor. We should know how to factor. We've been doing it for a long time in here. That's what we reviewed before spring break. So, simplifying a rational expression requires 2 steps. First, factor the numerator and denominator. Then, divide out any factors that are common. So, you see this example right now? Can I go ahead and do this? Can I do that? 1 step, done, right? No, it says there's 2 steps. What did I not do? What didn't I do, Ryan? When I did this, what didn't I do? I didn't factor. You can only cancel things if they factor out. So if you don't do the factoring step, you cannot cancel. So we're going to factor first. In our numerator, we have a greatest common factor of x. In our denominator, we can factor x squared to be x times x. I have factored an x and an x from the numerator and the denominator. I factored out an x, therefore I can cancel those factors. You can only cancel if they are factors. So this simplified expression would be x plus 7 over x. Can I cancel those? So I do see yeses in here, but that is not correct. What is the factor on top? Look before I got rid of the parentheses. What's the factor on top? Sophie, before I got rid of the parentheses from here to here, my entire factor is what? The entire factor, when I factored up here, I had x as a factor and I had x plus 7 as a second factor. Those are factors, things that multiply together to give me x squared plus 7x. So this x plus 7 is an entire factor. So when I went over here, why can't I cancel the x from it? It's part of a factor. You can't cancel part of a factor. You cancel the entire factor. If I want to cancel those something, let me get rid of this pink. If I want to cancel something here, what I have to do is say, what can I factor from x plus 7? What can I factor of x plus 7? What can I factor? Nothing? What can I factor from x? Nothing, other than the number 1. If you can't factor, you can't cancel. If you can't factor, you can't cancel. It's factor, cancel, okay? Keep in mind, even though I dropped the parentheses, they're understood to be here that this is a thing. This is a factor together. So I can't cancel part of a factor. It's all or nothing. Okay, so here's example 1. What should we do for, oh, I'm sorry, Jackson. The answer is this one right here. Sorry about that. Okay, so example 1, what do we do first? Brooke. Factor the numerator and the denominator separately. So I'm going to look at the top. It's a trinomial, so we're going to factor. Minus 6 plus 2. In the denominator, it's 2 terms, subtraction, difference of squares. Tessa, how do I factor the denominator?
The difference of squares.
How do I factor it?
It would be x plus 2 and then x minus 2.
Perfect. Okay, I have factored it. Now, are there any factors that are in common? On top and bottom. The x plus 2. If I cancel the entire factor, it's okay. So now I have x minus 6 over x minus 2. Can I cross out the x's and make this 3? Why not, Sierra? Because I can't cancel part of a factor. Is that what you were saying? I can't cancel part of a factor because I did not factor x minus 6. That is a factor. X minus 6 is a factor. If I try to factor x minus 6 further, it doesn't factor. If it doesn't factor, you can't cancel. This is almost the entire answer. There's something I haven't told you about yet. So we're actually missing part of the answer here, and that's what we're going to do on the calculator. Okay, so this is almost the entire answer. So what I want you to do on your calculator is we're going to go to just our graph, y equals, and clear anything that's in there. And we're going to type in both the original and the simplified version. Okay, if you have the newer calculators and you hit alpha y equals enter, it's going to be easy to type in as a fraction. If you have the older calculators, you'll just have to have a parenthesis around the top and a parenthesis around the bottom. So I'm going to type this in, and you should do the same. And then I'm going to type in my simplified answer for the second one, alpha y equals enter. Now, I'm not going to actually graph. So if you hit graph, we're not going to graph it. We're going to look to do something else. Am I waiting on anybody to type in? Okay, when I do this next thing, if yours doesn't work, let me know so I can fix your calculator right away. We're going to do second graph, which is a table. Do second graph, which is a table. Now, I just I moved with my arrows, my X column, so it starts about -3. If yours is like up in the 200s and you don't want to arrow all the way to -3, tell me and I can help you fix it really fast. Did you have trouble?
So how do you do this part?
Second breath. Anybody else need help? You guys see what I see? Did you get it? Or did you just get it? Is that when you type, when it's turned sideways? Is it when you go back into it, is it still turned sideways? Oh. Second. You're not gonna. Okay, so ow, zipper hurt me. So are these two equations completely exactly the same? Look at their outputs. Look at their y values. Are they 100% the same? They are not. So there is something extra that we have to put in because sometimes they're not 100% the same. At -2, the original equation has an error. The second equation has an answer. Let's look at the original or the work. At -2, the first equation has an error. The second equation has an answer when x is -2. They both have an error at +2. What happens if I plug in -2 into this parenthesis in the original question? What happens if I plug in -2 right here? What does this parenthesis equal when I plug in -2? Not a hard answer. Come on. 0. Can we divide by 0? So that's why there's an error on this one, on the first one. There's an error because if I plug in -2, this becomes 0. 0 times anything is 0. If I plug in +2 right here, not on the 2, sorry. Put that in the weird spot. If I plug in +2 for this x, 2 minus 2 is 0. That makes the denominator 0. And that's why we have an error on +2. They both have an error on +2. The first one's the only one that has an error on -2. Why? What happened from the first one to the second one? What happened to that -2? It lost its parentheses, is that what you said? Is that what you said? Yes, I'm going to word it a little bit more mathy. But yeah, like we canceled it out, right? We got rid of it. It's gone. We simplified. So what we have to say is in order for these to be completely 100% exactly equal, we have to add on that this expression cannot equal -2. Now they're completely 100% equal. That was the only difference, is that my simplified expression does equal negative. It has a -2 answer. So if we add in this little extra piece, now they're 100% equal. So what we're going to be doing is finding domain restrictions as well as simplifying. So if that kind of made sense or didn't make sense, we're going to do more examples. That is the final answer, what I put in the box. So I'm going to start and we're going to simplify this expression. What is my first step, Amar? Okay, we're going to factor. On top, we have x to the 4th minus 16. This is a difference of squares. When I factor that, it's going to be, and I'm putting it up, nah, I'll just write it normal. X squared minus plus 4 and x squared minus 4. That is not simplified all the way. That's not simplified all the way. We still have this difference of squares right here, so I need to factor it a little bit further. X squared plus 4 does not factor any further. It's a sum. But difference of squares, x plus 2, x minus 2. And then those are factored all the way because they're linear factors. In the denominator, we have to do grouping. Remember, I have to have a plus sign in between. We're going to take out x squared. So I have x squared times 5x minus 3. And then I'm going to take out 4. And I'll have 5x minus 3. So now I have x squared plus 4 times 5x minus 3. X squared plus 4 does not simplify any further. Okay. Now, after I factored it, what we want to do, and this is the new thing, what we want to do is we're going to find domain restrictions. We're going to find domain restrictions. Now, notice I haven't canceled anything yet. Find domain restrictions. So we're going to set each of these parentheses at the bottom, each of these factors equal to 0. Now, actually, I'm going to write it as does not equal to because I don't want it to equal 0. Okay. Now, if I solve each of these, let's see, this one would be x squared does not equal to negative 4. Then I'm going to square root both sides. I'll have to have a plus minus. What am I going to get here? Nina, do you remember square root of negative 4? Louder, huh? You can't have a real answer. Yeah, so it's like 2i. But you're right. It's not a real answer. So when we talk about domain restrictions, the imaginary ones don't matter. Okay? This imaginary one doesn't matter because it's imaginary. If it's real, it's going to matter. If it's imaginary, it doesn't matter. All right, and then the next one, 5x does not equal 3, so x does not equal 3/5. So this would be the only error that would show up on that calculator list. So if we type this one in, and you can totally type it in if you want, at 3/5, you would get an error. Now we proceed, and our next step is cancel. Does anything cancel? Any of the factors cancel? Holland, do any of the factors cancel? On top and bottom, none of the factors are the same? 4 is not a factor, but in parentheses, what would it be? The entire parenthesis. Right, the entire parenthesis is what can factor, x squared plus 4. So we've canceled those, and now I have left x plus 2, x minus 2 over 5x minus 3. Then we're going to check our domain restrictions one more time. X cannot equal 3/5. Let me just check it one more time. Has anything changed? Have the domain restrictions changed? Because I canceled stuff. Ari, you're shaking your head no. Ashlyn, what do you think? Have the domain restrictions changed?
No.
Why do you sound unsure? What are you thinking?
I'm not really sure if it changes when you cancel it.
So what were the domain restrictions that I had for that x squared plus 4? Okay, remember how I scribbled it out and I said it doesn't even matter because they're imaginary. So because it didn't matter, nothing changed. This was the only domain restriction before, and now this is the only domain restriction. They are the same. So nothing changed. So what I'm going to have for my answer is just x plus 2, x minus 2 over 5x minus 3. I do not write anything extra because there aren't any differences other than the negative or the imaginary numbers, but they're imaginary. They're not real. So that they don't really make a difference. Yes, Amon.
So after like each time you factor, do you like check for a domain restriction?
After you cancel. Actually, eventually it's going to be at different points. Just getting you used to something now before we add on more steps. Okay. For this type only, it would be before, after you factor, and then after you cancel. But when we get to more steps, it'll happen more often. Okay. I don't want to tell you that's the only time ever. And again, if you can figure it out right now, if I canceled it, it's going to be something I have to add into the answer. If you can figure that out, that's great, but it's not going to always be that way. I want you to guys know, like, don't make assumptions ahead of time. I wouldn't make you do all this work if there wasn't a reason coming up. Okay, so that's the only answer. Let's look at number 1. These are the student practices, but we're going to keep going. Number 1 is already factored for you, so you don't even have to do the first step. What should we do now? We've already factored. What should we do? Jacob, what should we do? Nope. What did he not tell me? Just added it on. Did everybody think he was right? Oh, because Jacob's normally right. I think you are most of the time. Brian, do you know? Emma, do you know? What did we do after we factored this guy? Did we immediately cancel? No, Jackson? What do we need to do? We need to find those domain restrictions. Let's find those domain restrictions. So x plus 1 does not equal 0. X plus 3 does not equal 0. X does not equal -1. X does not equal -3. There's my domain restrictions. Now, Jacob, what can I do? Cancel what? Excellent. X plus 1s, bye-bye. We get 2 over x plus 3. Now what do I do? Jackson, now what do I do?
Does it go back to like what we learned in the last image?
What are you thinking?
Where you do like the x and then the 2 over x?
No.
Okay, never mind.
So what we do now is we check our domain restriction again. After you do your domain restriction before you cancel, you do your domain restriction after you cancel. So now what's my domain restriction? X does not equal -3. Did anything change when I canceled? I had 2 of them here. I only have 1 of them now. Did anything change when I canceled? Yeah. So what we do is we write 2 over x plus 3 is our simplified answer, comma, x does not equal -1. You only write the domain restriction that you can't see in the answer. So if it's a domain restriction right here in the simplified version, if it's a domain restriction there, you don't write that as part of the answer because I know that already. I didn't know this unless I go back and look at the original question and all your work. Okay, number 2. What should we do? Yes, Amar, sorry.
I'm not really understanding like number 1. Like what we had to do to cancel that plus 1 and that plus 1. Like,
What did we have to do to cancel them?
yeah, because
We had to factor it. It was already factored though. Like it was already, like originally this would have been 2x plus 2. And so the 2 was already factored out. And in the bottom, it would have been x, I'll write it over here, x squared plus 4x plus 3, but it was already factored for you. So typically we're going to factor them first. That one was already factored.
But then like what you have to do, like what is that like true or like what is that?
Here, sorry, my thing stopped working. Can you repeat your question? It's your mask. I can't.
So you have written in the blue for number 1.
Oh, in blue
Yeah. I don't know if you feel like if I understand that.
over here.
Yeah.
So that is just taking every factor in the denominator and setting it equal to 0. The same thing that we did back when we were finding x-intercepts. When we would factor something and find the x-intercepts. We're taking the denominator, set each of them equal to 0. The reason why we have to do that is because you cannot divide by 0. Remember when we were graphing our rational expressions on the last section that you just took a quiz on? We had asymptotes. Remember we had asymptotes? And that's because there were things in the denominator that would make denominator equal to 0. We can't divide by 0. So these blue things are asymptotes. They're not always asymptotes, but we'll just call them asymptotes for right now. Let's do some more. It takes practice to like get it. And then you get it and you're good. And it comes up a lot in higher level classes. So, all right, next one, x plus 4 over x squared minus 16. What do we do first? Warren, what should we do first? Factor the bottom. Good. You already realized the top does not factor. So the bottom is a difference of squares. Now, the top does not factor, so I'm going to look at the numerator as being a whole factor by itself. It doesn't factor. I could pull a 1 out. I mean, I could do that if I want. But the entire top is just its own factor. All right, we factored. What do we do next? Ella, what should we do next? Domain restrictions. Perfect. So I'm going to have that x cannot equal -4 and x cannot equal 4. I kind of jumped to the answer by doing it in my head a little bit. Got my domain restrictions. I've got 2 of them. What do I do next, Tessa? What am I canceling? Okay. Because those are factors, I'm allowed to cancel them. On top, when I canceled out that x plus 4, Emma, what do I have left over on top? No, not just nothing. Did you say just nothing? It would be 1, yes. And then x minus 4 is in the numerator. Parentheses around it aren't important when it's the only thing down there, so I'm not going to write them. Now what do we do? Ashlyn, what do we do now? Yeah, domain restriction again. So x cannot equal 4. Did anything change from when we factored it till after we canceled it? Did anything change domain restriction wise? So our answer is going to be 1 over x minus 4, comma, x does not equal, what do I put? -4. I put the 1 that is not in my simplified answer. I put the 1 that disappeared. Number 3. Oh, I don't have Number 3. Do you see it's already factored? Okay. Anything I can cancel? Actually, technically, it's not factored. I mean, 4 could be 2 times 2, right? Is there a factor of a 2 in the denominator? Is there a factor of a 2? Just a 2 by itself, not in a parenthesis with an X. There's not just a factor of 2. So it's factored, nothing cancels. This is already simplified. There's nothing I can do. Move on. Number 4, what should we do first? Katsia, what should we do first? Factor. Good. I'm going to factor it quickly because of time. X minus 3, x plus 1. And in the denominator, x minus 3, x plus 2. Factored. Sierra, what should I do next? Domain restrictions. Perfect. So we've got x cannot equal 3 and x cannot equal negative 2. Domain restrictions. I've got 2 of them. FOD, what do I do next? Simplify, cancel, right? Cross stuff out. What am I crossing out? The x minus 3s. Good. So now I have x plus 1 over x plus 2. Holland, what do I do now? Domain restrictions. So x does not equal negative 2. There's only one of them. That must mean that in my answer, we're going to have to put a domain restriction in. X plus 1 over x plus 2, comma, Warren, what should I write with it? X does not equal 3. Yes, Sophie.
How are you knowing which numbers to pick?
So I have 2 of them here. I've got domain restriction 1. I've got domain restriction 2. Yeah. And then over here, I only have domain restriction 2. So I have to put in the one that's missing. I have to put in the 1. Oh, in my head, I'm doing x plus 2 equals or not equal to 0, and then subtracting the 2. And so I get x does not equal negative 2. I'm just, because these are simple, it's just x and a number, I'm just moving that number over in my head. Because 0 can be on the top of a fraction. We cannot have a, that's so messy, hold on. We cannot have a number over 0 ever, but you can have 0 on the top. Good question. Why doesn't the top matter? Because we can have 0 on the top. Just can't have 0 on the bottom. Okay, now we're going to multiply. Oh my gosh, more. Right? No, just kidding. Okay, so I'm going to multiply. This one we've just got, there's no plus signs. It's just all monomials. So we're going to multiply straight across, and you guys should remember when we multiply straight across fractions, straight across, we don't need common denominators when we multiply. We would multiply the numbers 56, and then what do I do when I multiply x cubed and x to the 4th? What do I do when I multiply x cubed and x to the 4th? Add what? The exponents. So we will add 3 plus 4 and get x to the 7th. Y to the, how many y's will I have out there? Yell it out. 4, because there's a 1 here and a 3 here. So we have y to the 4th. Over 2 times 4 is 8. X with no other x's is x. Y squared and another y is y to the 3rd. So we did that in chapter 5. It's been a while. I mean, it's not been a while. We've been doing it for a while is what I meant. Okay, now we're just going to simplify. So 56 over 8, does that reduce? What is it? 7. X to the 7th over x. So that's like x to the 7 minus 1. Y to the 4 minus 3. Oh my gosh, I totally forgot to do something. You guys should have stopped me. I didn't factor because this is kind of like all separate factors, and I don't want to write out 2 times 2 times 2 times x times y times y times y. I could factor it. I just don't want to, okay? After you factor it, what do we have to do? I forgot to do the step. After we factor it, what do you have to do? Same on here. After we factored it, what did we do? We did do domain restrictions. So in the denominator, I have variables. So what can x not equal? This is a factor. 0. But y is also a factor. And y is a variable. So what can y not equal? 0. If they're just factors by themselves, if it's just x, it's 0. If it's just y, it's 0. Fine. Sorry about that. Forgot to do that earlier. Okay, now we go back to where I was simplifying. We have 7, we have x to the 6, and we have y to the 1st. Now we check our domain restrictions again. Where is my denominator? Where'd it go? It's gone. I simplified it out. So what are my domain restrictions in 7x to the 6 over times y? What are my domain restrictions? There aren't any. So if there's no domain restrictions, then that means something changed. So my final answer for this one is going to be 7 x to the 6y, comma, x does not equal 0, and y does not equal 0. So you can have multiple domain restrictions. Okay. Multiplying when we have polynomials rather than just monomials. Polynomials have multiple terms. Factor. Factor first. Factor. Let's see, on this first one here, we've got 3x comes out times 1 minus x over x plus 5x minus 1. And then x plus 5x minus 4 over 3x. Okay, I'm not going to go on yet because I want to draw your attention to something that really bothers me. And I don't know if it bothers you, but it really bothers me. Does it bother anybody else that this says 1 minus x and not x minus 1? Does that bother anybody else or just me? I got a little OCD issues. Okay. Are they exactly the same? Is 1 minus x the exact same thing as x minus 1? It is not. So I'm going to fix the fact that I can't stand the way it looks right now, and I'm going to make these look exactly the same. So instead of me taking out 3x, if I had rearranged this to be negative 3x squared plus 3x to begin, if I had rearranged it, you would say, oh, you need to take out a negative number because that's what we do when we factor in it starts with a negative number. So that's what I'm going to do. I'm actually going to take out negative 3x. When I take out negative 3x, I'm left with x minus 1. Okay, so now they look the same. That's going to be important, don't you think? Probably important. Okay, so we factored it. Now what I'm going to do is find domain restrictions. X does not equal negative 5. X does not equal positive 1. And X does not equal, what's the last one? 0. We've got 3 domain restrictions. Now, if you want, you can go ahead and cancel those x minus 1s that are on top of each other. You can do that here. I'm just going to multiply it first. It doesn't really matter which order, if you cancel first or multiply first. I'm just going to multiply first. And you guys, you got to pay attention to this because it's going to go so fast. It's going to blow your mind. I'm going to multiply these together. Are you ready? You guys paying attention? It goes really fast. When we multiply fractions, we go straight across, right? These are already factors. I'm going to multiply these together. When I multiply them together, this is what I get. That's my fraction. I multiplied them together. Top goes on top. I'm just joking about blowing your mind. Top goes on top, bottom goes on bottom. Like that's the new fraction. I multiplied it together. That's it. Don't know if my sarcasm / lack of humor has gone over here. All right, so I've multiplied them together. Now let's cancel. What can cancel? The x minus 1s. Anything else can cancel? Ooh, the x plus 5s. Anything else can cancel? So one of them's negative 3x, one of them's positive 3x. When I look at that negative 3x, it could be negative 1 multiplied by 3 multiplied by x. This 3x is the same thing as 3 multiplied by x. So what is actually canceling? The 3 and the x. That's what's canceling. So we still have that negative 1 out there. So I'm going to rewrite what I have. I have a negative 1 times, I don't need the 1 part, negative times x minus 4 over, oh, did we cancel everything out of the bottom, huh? So not over anything. So what are our domain restrictions? What's in the denominator here? What is my denominator? So what variables are in the denominator? If there's no variables, there's no domain restrictions. Okay, so if it's over 1, there's going to be no domain restrictions. So we've got negative x minus 4, comma, x does not equal negative 5, x does not equal 1, and x does not equal 0 as our final answer, because all of those canceled out. So looking at example 4, I have a fraction multiplied by not a fraction. You guys, when you did, I don't know, like 3/5 multiplied by 7, how do you do that? You put 7 over 1 and then you multiply straight across. Same thing. We're going to put this over 1. We're going to multiply straight across. But first, we're going to factor. So on top, x plus 2 does not factor. On the bottom, this is cubes. We reviewed those a teeny bit before spring break. There is a formula for it. I'm going to write it down like really super fast. If you don't get the formula down, you can just like Google it. It's all over the internet because everybody's doing it. Okay, so the denominator x cubed minus 27. It's, oh, also you could rewatch the video if you didn't get that down in time. X cubed minus 27 is going to become x minus 3 times x squared plus 3x plus 9. And then I've said this before, when we factor cubes, this part will never factor further. It won't factor anymore. And it won't have domain restrictions either, because if you solve this, it equals imaginary numbers. So it won't have restrictions. So when I factored it and I got this part here, there won't be any domain restrictions for that. Yes. Yeah. So b is 3. And then b squared would be 9. B cubed is 27. Okay, so I'm going to find my domain restrictions, and I will have that x does not equal 3. But I will not have a domain restriction if I factor cubes. Yay, less work. Now I'm going to multiply these two fractions together. Here I go. I'm multiplying them, and they're multiplied. Can anything cancel? That big ugly thing? Yes. So we get x plus 2 over x minus 3. Check my domain restrictions. X does not equal 3. They are the same. That means when I write my answer, I don't write anything extra. If the domain restrictions are exactly the same, you don't have to write anything extra. So I've gone through everything. The rest is just student practice. If you get stuck on this, this is definitely something you want to work ahead on so that you're not coming in after we've started the quiz asking questions. You know, come in 10 minutes early if you definitely have questions before we take the quiz. Come in XH tomorrow. Send me a message tomorrow night. But the assignment's going to be due tomorrow night. I'll get it up early. I got up the last one. Yesterday's earlier than normal.